Good morning. Myself, Dr. Maheswara Rao, Department of Civil Engineering, Institute of Aeronautical Engineering. So our course name is Fluid Mechanics, and the topic is classification of fluids flows with respect to time and space. The course outcomes. The course outcome means of the completion of any topic, any course, the student will be able to do or get the knowledge. That is the course outcome. So course outcome one is the definition of fluids and their properties. So the properties of fluids and the definition of fluid will be known by the student. That is the course outcome one. Whereas the course outcome two is the classification of fluids based on Newton's law of viscosity. So if the fluids are obeying Newton's law of viscosity, those are called Newtonian fluids. If the fluids are not obeys the Newton's law of viscosity, then they are called non-Newtonian fluids, and some problems related to that. So is course outcome 2. So course outcome 3 is the capillary rise or fall. That means whenever a smaller diameter tube is inserted in a fluid, some fluids will rise the level inside the small diameter tube, which is called capillary rise. Whereas some other fluids, if you insert a smaller diameter tube in that fluid will lower its level in the smaller diameter tube. So which is called capillary fall. So that is the course outcome 3. So course outcome 4 is the surface tension. That means any fluids at the surface, it will have some tensile forces. So that is called surface tension, because the tension is there on the surface. That's why it is called surface tension. So that is course outcome 4. Course outcome 5 is the compressibility. So that means the application of external forces, if any fluid changes its volume or changes its density, so those are called compressible fluids. So some fluids, even application of the external forces, they will not change their volume, they will not change their density. So those are called incompressible fluids. So gases are the compressible fluids, so that they can change their volume and also density. Whereas the water is the incompressible fluid, which will not change. That means water will not change its volume, or water will not change its density with application of the external forces. So that is the course outcome 5. So course outcome 6 is the pipe flow, frictional losses. That means whenever fluid is flowing in the pipe, so there will be frictional losses or energy losses. That is the surface, inside surface of the pipe material and the fluid surface will have frictional forces while flowing. So because of that, frictional losses will occur. So that means energy will be lost if the fluid is flowing from one point to another point. So that is course outcome 6. So today's topic is a classification of fluid flows with respect to time and space. Classification of fluid flows means fluid will flow in a pipe or anywhere. So based on the flow, the classification is done. Okay. So previously, classification of fluids based on the Newton's law of viscosity. So which obeys the Newton's law of viscosity, Newtonian fluids, which does not obey the Newton's law of viscosity, they are called non-Newtonian fluids. Here, different thing. Here, the fluids flows is classified based on the that means with respect to time and space. So here, if we see the time, based on with respect to time means what? If we check the property at this particular time and after a certain period of time also if we check their same point, the properties will not change. That is with respect to time. Or if changes with respect to time also, fluid flows classification is there. Similarly, space. Space means if you check the property of fluid at a particular point A, and at the same time if you check the property of the fluid at some other point like B. So if there is a same property or if there are different properties, so based on that, the classification of fluid flows is done. So initially, we'll see the classification of fluid flows with respect to time. So that means we'll consider it is a time. So based on that time, that means you are knowing this, that means testing the properties at any point of time. If it is changing or if it is not changing, based on that, the classification of fluid flows is done. That is with respect to time. So you can see here the definition, what is stated here, told means a fluid flow is said to be steady. So here the first fluid flow classification is steady flow. So what is the steady flow here? If the velocity of fluid at any point does not change with time. Okay, that means if you take this point, now it is 2:30 p.m. let us take. So come by 4 p.m. So again you check the same point. Okay, so it is the velocity is not changing. So if velocity does not change with time, any time if you check the velocity in this at this particular point, okay, fluid flow velocity at this point at any time, it may be 9 o'clock, 10 o'clock, 11 o'clock, all the times, if it is having same velocity, so then that flow is called steady flow. So steady flow means velocity will not change at a particular point with respect to time. Any time the velocity remains same. So the velocities remain same. That is called a steady flow at a particular point. Okay. So if you see the mathematical representation, okay, so that is steady flow is denoted as dou V by dou T is equal to 0. That means you take it with respect to time. Dou T means T is the time, V is the velocity vector. Okay. So if you take the velocity at any point of time, it will not change. Then that is equal to 0, which is a steady flow. So examples for this steady flow are water flowing steadily through a pipe. So if water is flowing through a pipe, this is a pipe. If the water is flowing, there is a steady flow. Or air flow over a wing at constant speed. Okay. So air flow, that means air flow over a wing at a constant speed. So that is the example for the steady flow. That means velocity of flow, velocity of fluid is constant here. That means same. It is not changing. That is the dou V by dou T is equal to 0. Then characteristics. So what are the characteristics of this steady flow? Okay. So what is written here? Properties like pressure, density, velocity are constant over time. Okay. So as per mathematical formulation, dou V by dou T is equal to 0. That means velocity is not changing at any point of time. Same velocity. And also characteristics are pressure, density and velocity also. So pressure is also not changing. Density is also not changing. So same pressure, same density, same velocity over a time. So at any given particular point. So if it is, take a suppose this point, any time, point of time. So morning 5 o'clock or 6 o'clock, evening 5 o'clock, like that. So for a given period of time, if it is constant, that means pressure is constant. Okay. That means same pressure it is maintaining at any point of time, or same density rho if it is maintaining, same velocity if it is maintaining at that particular point at any point of time over a time. If it is constant, then that is called steady flow. So examples are the streamlines are fixed in space. So streamlines are fixed in space, then it is a steady flow. So what is the meaning of steady flow means? If you measure the pressure at a particular point A at any time if it is not changing. If you measure a density of fluid at a particular point like A, it is not changing. The density is not changing at any time. And velocity, if you measure at a particular point A, the velocity is not changing for a particular period of time. Okay. So on that particular period of time, it is not changing at all. So that flow is called steady flow. Okay. So unsteady flow. So reverse of this steady flow definition. So what is the steady flow definition? It is dou V by dou T is equal to 0 is the steady flow. So if you put not equal to 0, then it is the unsteady flow. That what does it mean? The velocity will change with respect to time. So if you take a point A, so now if you measure, it will have some velocity fluid. And some other time it will have some other velocity. That means velocity is changing. Velocity is changing with respect to the time. So that is called a unsteady flow. So if you see the definition, the flow is unsteady if the fluid velocity at any point changes with time. So if velocity changes with the time, then that is called a unsteady flow. So mathematical representation for this is dou V by dou T is not equal to 0. That means V is not same. V is not constant. V is changing. Okay. So examples are the gust of wind, pulsating flow on blood vessels, water waves. So all these are the different examples for the unsteady flow. That means velocity is changing. It is not constant, it is not the same for throughout the time at a particular point. So if you take the gust of wind or blood vessels, so pulsating flow in the blood vessels or water waves, so it is every second the velocity is varying at that particular point. So then that flow is called unsteady flow. So characteristics, if you see the characteristics, velocity, pressure, density. So these three things are there. Steady flow also, these three parameters are there. What are those? One is velocity, another is pressure, another is density. So if they are constant at any time, they are called steady flow. If they are not constant, that means if it is varying, velocity is varying, pressure is varying, or density is varying at any time, that means with respect to the time, then that flow is called unsteady flow. So that at any point A, so if you take a pipe or something, if you take A point, so you can measure the velocity at A point, or you can measure the pressure at A point, or if you measure the rho density at A point at different times, at different times. So then it is not the same, then that is unsteady flow. If it is same, that is the steady flow. So till now we classified the fluid flows based on the time with respect to the time. That means steady flow, unsteady flow. So steady flow means velocity is not changing, pressure is not changing, density is not changing with respect to time. Any point of time it is same. That is steady flow. If the velocity is changing, or pressure is changing, or density is changing with respect to time, that means if you measure now, it will give some velocity at other time period, at the same point, it is giving another velocity. So velocity is varying, or pressure is varying, or density is varying at a particular point with respect to the time. That is a unsteady flow. Now, with respect to the space, how these classification of fluids are classified? Fluid flows based on space. What does it mean, space here? Space means particular distance. Just like here. So let us take this is A point, this is B point. So from A point to B point, how this flow is there. So in this first one is uniform. So what is written here? The flow is to be uniform if the velocity of the fluid at a given instant is same every point. That means if you measure from A to B, so wherever you measure, it gives the same velocity at a given point of time. That means at 2 p.m., if you measure, in between A and B, everywhere you will get the same velocity. Or 2:30 p.m. Okay, if you measure, so at that particular point of time, if the velocities are same at any point between the A and B, so that means if a pipe is there, it is A, it is B, you can measure here, anywhere. But time is same time. So if you measure here 2 p.m., here also 2 p.m., here also 2 p.m., here also 2 p.m. So at a given point of time, okay, at a given, it is just opposite to the steady flow. There at a given point, location, but different times. Here uniform flow means at given point of time at different locations. So just opposite that one. Okay. So at a given particular point of time, if you measure anywhere in between A and B, if it is maintaining the same velocity, that is uniform flow. So mathematical representation is this: dou V by dou S is equal to 0. That means with respect to the space. So anywhere, if you measure the velocity should be same. Anywhere, wherever you want, anywhere in between some points A and B. Let us take a point between A and B points. Anywhere if you measure, if the velocity is same, those are called uniform flow. So no change in the velocity with respect to space, that is called the uniform flow. That means dou V by dou S is equal to 0. So whereas non-uniform flow is very opposite. So dou V by dou S is not equal to 0. That means the velocity is not same at different points at a given point of time. That means let us take 3 p.m. 45 minutes. If you measure a velocity at different points in your pipeline, if each and every point is having different velocities, then that is a non-uniform flow. That means dou V by dou S is not equal to 0. That is non-uniform flow. So mathematical expression for this uniform flow is dou V by dou S is equal to 0. So what is the S here? It is nothing but the spatial coordinate along the direction of flow. So that means if a pipe is there, okay, this is the fluid flow direction, okay. So the spatial coordinate, here is one point, here is another point. So between these A and B points, okay. So that is the S. Those are the spatial coordinates. Examples. So flow of water through a long straight pipe with constant cross section. See here, what is the constant cross section? Or flow over a flat plate. Constant cross section means same diameter. If the diameter is same and long, then wherever you measure here, you will get the same velocity. Here is V1, here also V1, here also V1, like that. But at a given point of time. So that is the uniform velocity. So that's why it is given constant cross section. Okay, that means same diameter of the pipe. So what does it mean? Means if the diameter is varying, then velocity will be changes. Velocity will change because Q is equal to A1 V1, that is equal to U2 V2 as per this formula. Okay, if area is reducing, okay, so what will happen? V will increase. So because A1 V1 is equal to A2 V2, so something is reducing, other thing is increasing. So whenever, if A are constant, V is also constant. If A is different, that means varying pipe. So like this, varying diameter. Here is diameter something, here is diameter is different. So as areas are different, velocity is also at this point of time, it is V1, here it will be V2. So different velocities will be there. Then that flow is called a non-uniform flow. So characteristics. So velocity and other flow properties are constant along the direction of flow. So those are constant. So streamlines are parallel and equally spaced. So those are the uniform flow. Non-uniform flow here. So non-uniform flow is exactly opposite to uniform flow. So you can see in this formula, mathematical representation, dou V upon dou S is not equal to 0. So that means the velocity is not same at different points in a pipe at a given point of time. That is the non-uniform flow. So here you see a definition. The flow is non-uniform if the velocity of fluid changes. The velocity of fluid changes. The velocity is different, okay, from one point to another point along the direction of flow. So then that is a non-uniform flow. So steady flow, non-uniform flow, what is the difference? Non-uniform flow means we are measuring the velocity at different points, but at the same time. That is the non-uniform flow. Unsteady flow means what? We are measuring the velocities at a given point of time, at a given point of location, at any point, at any time. Say now, tomorrow, like that. So, time gap, but no change in the velocity. So, examples. Flow through a pipe varying cross section. Flow around an obstacle. That means if the same diameter pipe is there, velocity will be constant. That is uniform flow. The pipe is varying. That means here is D1 diameter, D2 diameter. Fluid is flowing. So then velocity at this point is different. V1, V2. So velocity is changing with respect to the space. So in case of varying diameter of pipe. So that is the non-uniform flow. So dou V by dou S is not equal to 0. Characteristics. So velocity and other properties vary with the location. So from one location to another location, if velocity is varying, then that is a non-uniform flow. Streamlines may converge or diverge or curve shaped are the examples. So then you can see the combined classification. So till now we discussed the separately, that means with respect to time, that is steady flow, unsteady flow. With respect to space, that is uniform flow, non-uniform flow. Now it is combined classification. So what is that you can see now? Steady uniform flow. What we told is steady flow. Steady flow means if you measure velocity at this A point, let us take this V1. After some time also it should be V1. Then that is a steady flow. Whereas uniform flow, if you measure at velocity at A at V1, B also V1, but A and B velocities are measured at a certain point of time, given point of time. That is a uniform flow. So here, steady and uniform flow. So what is the definition here? A flow where velocity is constant both in time and space. That means with respect to time also velocity is same. With respect to space also velocity is same. Then that is called steady uniform. So examples, water flowing at a constant rate through a straight pipeline with a constant diameter. Okay. So here pipe is there, constant diameter. So this dia is constant. That means it is not varying diameter. And it is a straight pipe, not a curved pipe. It is a straight. Constant diameter and straight pipe. So constant rate. So constant rate means discharge. Same quantity of water per second is passing through that. So if these are there, then that is the example for the steady uniform flow. So that means if you measure any time, the velocity will be same. If you measure anywhere, velocity is same. That means with respect to time or with respect to space, velocity is not changing. Then that is steady uniform flow. Similarly, steady non-uniform. So steady means what? So if you measure any time at a particular point, that is a steady flow. Non-uniform flow means at different locations, if the different velocities are there, then that is a non-uniform flow. So if you see the definition for the combination, a flow where velocity does not change with time but varies with the location. So that means if you take a pipe at this particular point A and this is point B, the velocity is not changing. Now afterwards also V1, yesterday also V1, like that. So same velocity at a particular location, that is a steady flow. But velocity at B is different, V2. Then, it's because velocities are different at different locations, then that is called non-uniform flow. So that is called steady non-uniform flow. So if you see the examples, so water flowing at a constant rate through a pipe with varying diameter. So this varying diameter, this is the figure for the varying diameter pipe. That means the diameter is not same. So it will have some different diameters at different locations. So that is the example for the steady non-uniform flow. So if you take a point, it is giving same velocity at any time. But here also same velocity at any point. But if you compare this A and B points, the velocities are not same. So that's why different locations, velocity is not same. That's why it is a non-uniform. So combinedly it is called steady non-uniform flow. Unsteady uniform flow. So unsteady uniform flow means what? Unsteady means if a flow is there, if you measure here, now it is V1, after some time V2, after some time V3. So velocity is changing with respect to time. That is unsteady flow. Uniform flow means what? If you measure at A point, B point, velocity will be, if it is V4, here also V4. So at different locations, velocities are same at a particular point of time, but velocities are varying with respect to time at a particular point, particular location. That is that means it is not a varying, that is unsteady flow and uniform. Examples, a tidal wave moving through a ocean where at any given point of time, velocity is same everywhere. So velocity is same everywhere. There will be different locations, velocity is same. That is uniform. But different points of time, velocity is not same. That is unsteady flow. Unsteady non-uniform flow. Unsteady non-uniform flow. That means at any point of time, that means with respect to time, velocity is varying, changing, and also at any location, velocity is varying. So both these are there. That is called unsteady non-uniform flow. That means if the velocity is varying with respect to time or with respect to space, velocity is changing, then that flow is called unsteady non-uniform flow. So if you see the definition, a flow where velocity changes with both time and location, then that is called a unsteady non-uniform. So a turbulent flow in a river or airflow around a moving vehicle. So if vehicle is moving, so airflow, how it is an unsteady non-uniform. Or turbulent flow in a river. What is the turbulent flow means? So river water is flowing like this. Then if any rock is there, so it hits and it fastly goes up down and falls here. Then that is called a turbulent flow. So in the turbulent flow, the flow is unsteady flow. That means at different times, different velocities, and velocity is also changes at any location. At A point, at B point, the velocity is not set. That's why it is called unsteady non-uniform flow. So if you review what we learned today, so today we learned the classification of fluid flows. Okay. The classification of fluid flows, here it is here. So here, with respect to the time, there is a steady flow. That means velocity is not changing with respect to the time. That is a steady flow. So mathematical representation is dou v by dou t is equal to 0. It is not varying. V is the velocity vector, t is the time. And unsteady flow. So unsteady flow means here the velocity is changing. So velocity is not constant. Okay. At any given of time, then that is unsteady flow. Mathematical representation is dou v by dou t is not equal to 0. That means velocity is not same at different points of time. That is unsteady flow. So now, with respect to the space, classification based upon the respect to the space, that means it different locations, space means. So uniform flow. At different locations, location points, the velocity is same, then that is called a uniform flow. So that means dou v by dou s is equal to 0. So S means space. So at particular A point, B point, C point, any point, the velocity, same velocity is there. That is a uniform flow. So same diameter pipe will have normally uniform flow. So non-uniform flow. That means at different locations, velocity is different. That means the diameter of the pipe is not same. So if diameter of pipe is varying, different diameters, then velocity will be changing from one point to another point. So which is, if the velocity is changing at different locations, that is a non-uniform flow. So this mathematical representation is that dou v by dou s is not equal to 0 here. And combined classification, that means a steady, unsteady, uniform, non-uniform, combination of steady, uniform, like that. So steady uniform flow. Steady uniform flow means at any point of time the velocity is same, that is steady flow. At different locations velocity is same, uniform flow. So that means the definition is that velocity is constant both, okay, with respect to time, with respect to space. That is called a steady uniform flow. So example for this is a long strike pipe with a constant diameter. So steady non-uniform flow. So steady non-uniform flow means here, steady means at any point of time, there is a different points of time at same location, velocity is same, that is steady flow. At different locations, velocity is not same, that is non-uniform. So steady non-uniform flow means you can measure same velocity at different points, different times. Whereas at different locations, it is not same. So that is called steady non-uniform flow. Example for this is the pipe is having varying diameter. So in other words, unsteady uniform flow. Unsteady means at different points of time, velocity is varying. That means with respect to time, velocity is changing, not the same velocity. Now with different velocity, some after time, different velocity. So, but all the locations, velocity is same. So that's why with respect to time, velocity is not constant. That's why unsteady. At different locations, velocity is same. That's why it is uniform. So unsteady, uniform flow. Unsteady and non-uniform flow. So that means with respect to time, velocity is varying. With respect to location also, velocity is varying. Both. So that is called unsteady non-uniform flow. So that means a flow changes. A flow of the velocity of the flow changes both time and location. So now after some time, velocity is varying. A point to B point, velocity is changing. So that's why the flow is called unsteady non-uniform flow. Examples: turbulent flow, array flow and a moving vehicle. References. So K. Subramaniam, Theory and Applications of Fluid Mechanics, Tata McGraw-Hill's 2012. Modi, PN and SM Seth, Hydraulics and Fluid Mechanics, Standard Bookhouse 2002. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.